All right, so adding and subtracting rationals. You can only add or subtract rationals if they have the same denominator, same basis, like basis, okay? If they don't have like basis, you can't add or subtract unless you find the common denominator. So let me go back and kind of jog your memory, okay? I'm going to add a page here. You do not have to write this. You do not have to write this, okay? I just want you to watch. If we were to have, let's see, five-eighths, right? That's 5/8 of a Hershey's bar. Let's say that. Hershey's bar has how many pieces? 16 little pieces, right? It's supposed to be 1, 2, 3, 4, and then it has 8. Okay? So for this half, out of 8, that's 1, 2, 3, 4, and 5, right? And then let's say I'm adding 7/8 to that. How many of the little rectangles of Hershey's do I have? It would be all of the 8 and how much more? 1, 2, 3, right? 4, 2, 3, that's 6 and 7. That'd be 3/4 of a whole bar. But if we were to cut it into 8s, that's what it looks like, right? We have to have the same denominator because we need the sizes of each piece that we're adding to be the same. Same idea, we need to make sure that we have the same denominator for 3 over x, plus x plus 2 over x. Do we have the same denominator there? Yes. You don't add the x's. You do not add the denominators, ever. So you should leave it as just x. Okay, once you have a common denominator, it just translates to what kind of size pieces do I have, okay? And then the numerator, we can simply add, just go 3 plus x plus 2. Next step, we want to combine like terms so we can simplify the numerator. Which ones are the like terms? 2 and 3, which makes it 5. So we have 5 as our constant, and then we have our x over the x. Okay, now I need you to remember something because I saw at least 3 people doing this. Don't kill kittens like this, please. No, don't do it. And then you tell me it's 5. It doesn't make sense. Who wants to know why it doesn't make sense so you never do it again? Okay, I'm going to explain why it doesn't make sense. Okay, let's say if x is equal to 3. Okay, if x is equal to 3, then this fraction, x plus 5 over x, is going to be 3 plus 5 over 3, right? What's 3 plus 5? 8. Is 8 over 3, does 8 over 3 have a 3 over 3 in common? Yeah. Does 8 have a factor of 3? No. No, you can't simplify that. Okay, we're not subtracting them. We're going to factor them out. We're separating out factors to simplify numerator to denominator, right? And if we don't have it, we can't do it. So if I were to say, oh, 3 goes into both, all right, then what's going to come out of the 8? Do you see the problem here, right? So then 8 over 3 is not equal to, what is it? I don't know. Would it be 5 over 3? Or 5 over 1, right? That would be what you're saying if you knock out the 3 over 3. Does that make sense? Yeah.
So if it was like, instead of like x plus 5 If it was like 5x, would you be able to cancel out the x's?
Yes,
Okay.
because it's multiplying. That's what I'm trying to tell you. Those multiplying relationships are dating relationships that can be simplified, right? But married couples are a little more complicated. You need to keep them together. So this is basically saying this is one value together, okay? If you say these are two separate values being multiplied together, it's not true because x plus 5 means it's the same x as what's being used in the denominator plus 5 more. Every time, no matter what the x is, okay? So we can't make this happen because we don't have 3 over 3 in 8 over 3, okay? Does that make sense? So please don't do it. Please don't kill kittens. We like kittens, don't we? Even if someone like me that's allergic to it, you guys all like kittens, right? All right, so here we go. I'm gonna delete those. So do not x plus 5 over x. Don't cancel these and say it's 5, okay? Because this is the reason. Because dot, dot, dot. So you have something to refer to later, okay? Questions? No? Did that make sense? Why it's a no-go now? Okay. 5 over x plus 2 minus n plus 1 over n plus 2. Now, yes, do you see the n over n? Can you simplify that? Say no. You should say no because I just explained why we can't, right? If I have 2 plus 2 plus 1 over 2 plus 2, is that same thing as simplifying that? 3 over 4? You can't do that, right? All right, so we can combine the numerator. We keep the denominator as it is, n plus 2. And then numerator would be 5 minus. Now, watch out for this. Remember I told you this is one quantity? That means if I apply the negative to this binomial, it needs to go to both n and the 1. So it's like this. N plus 1, like that, the quantity, and make sure you distribute that negative to each of those guys. Okay, so that would be 5 minus n minus 1 over n plus 2. Combine like terms again. 5 and negative 1 makes, careful, 4 or negative 4? Oh, that was me. My bad. Thank you. Negative n plus 4. So yesterday was worse. I said 2 times 3 was 5. Oh my gosh. No, I didn't even say that. I said 2 plus 3 was, what did I say yesterday? It was so bizarre, like so random. It was 2 times 4 is 5. That was not even close. That's what I did yesterday. Sorry. All right, so is this it or can I simplify more? You're doing the same thing as killing kittens with n over n. 4 over 2 cannot be simplified. It needs to be simplified as a binomial factor if you're going to simplify them. Okay? Since there's no GCF, there's nothing else to simplify. Okay? All right, so let's hold off on the unlike. Flip over to page 13. Page 13. Where it says with like basis. They look so similar. I'm trying to emphasize that it's a different page. Page 13. Okay? We're going to do that example right there. And then I'm going to have you guys choose which one you want me to cover. Okay? So step 1, to add, subtract rational expressions with a common denominator, you're going to combine the numerators and keep the common denominator as it is. Do not double it. Okay? Factor and simplify the remaining expression. So, do we have common denominators here? Yep. So I'm going to keep it as they are, leaving me with 4x squared plus 5x minus 6. Okay. Numerator can be combined. So I'm going to combine x squared plus 5x. That's a minus sign, so we're going to put a minus sign in front of the 3x. 3x is not same as 3 plus x. 3x is just one single term. So you can combine that without worry. Okay? So just put minus 3x. Remember how I said you can't just knock things out? How can we knock things out? Like, how can we simplify things? That's why it says right here, factor and simplify the remaining. Okay, so let's go ahead and factor the numerator. No, we can't factor that. Duh. All right, Miss Bion's really out of it. 5x minus 3x. Those are like terms, yes? Let's combine them. What do you get? 2x, positive 2x. And then we still have the x squared over. And then 4x squared plus 5x minus 6. Can I factor the numerator?
Yeah.
What do you see? I have a GCF of x, right? So I'm going to factor out the GCF x. Then I'm left with x plus 2. All over. And then we're going to use what to factor that one? Is the a 1 or is it something other than 1? It's other than 1, so you have to use the box. There are some people in here that have gotten kind of lazy about using the box because a has been 1 most of the time. But if you don't use the box with your a that is not equal to 1, you're going to have the wrong factors, okay? So make sure you finish off with using the factors, okay? So here we go. 4x squared goes on the top left. And negative 6 goes on the bottom right. Negative 24x squared at the top. And then the bottom of it will be the middle term, 5x. Two numbers that multiply to get negative 24 and add to get 5. 8 and 3. And it has to be, like Michelle said, negative 3x. Okay. Questions on those two terms we figured out just now? No? Okay. So I'm going to place these in the box. Okay. If you didn't do the box, this is what people are doing. They're writing the factors as x plus 8 and x minus 3. Okay. Yes, you can do that if a is 1. If a is not 1, watch what factors come out of this. Okay, so we have 4x and negative 3 and x and 2. Are those the same factors? No, not even close. So make sure you guys factor all the way through if a is not 1. Okay. Questions? So far, so good? Anything we can simplify here now? X plus 2 are matching couples with x plus 2 in the denominator, so we can simplify those. Then I'm left with x over 4x minus 3. Okay, questions? No? What? No questions at all. All right, then. You pick 1 through 20. Do as many as you like. Okay. I will give you about 15 minutes, 10 minutes? 10 minutes for you to try as much as you want. Ask me as many questions as you can to make sure that you understand how to add and subtract with like bases. Because here's the reason why. I'm going to move into unlike bases, and it's a whole lot more steps. It's not like multiplying to division where there's just one more added step. It's a whole lot of other steps. So make sure you're confident with like bases, adding and subtracting like bases, and then we're going to cover the next part, okay? So